We are going to focus in this video on trigonometry, and this will be dealing with the basics from grade 10. Alright, so we have trigonometry. First, what is trigonometry? This is the relationship between sides and angles of a triangle. Remember the word try again. Do you remember? You've heard the word try. Try from here. Triangle. Alright, the relationship between sides and angles of a triangle. In this basic video, we are going to start by dealing with a right angle triangle. And when we say a right angle triangle, we mean that one of the angles is actually equal to 90 degrees. Alright? So we have one of the angles equal to 90 degrees. So we are going to look at a right angle triangle quickly and understand the sides and the angles of this right angle triangle. So we have a right angle triangle. A right angled triangle. Before we go on, there are certain words we need to get accustomed to. We are going to talk about the sides. From previous grades, we know we have a side called the hypotenuse. Alright? We're going to introduce a side called opposite, and we are going to use the third side as adjacent. We will see what the opposite angle is right now. The hypotenuse is the angle, it's the side. Let's start by saying it is the longest side facing the angle 90 degrees. Alright, the longest side facing the angle 90 degrees. The opposite side is the side facing any angle in question. And the adjacent side is simply the third side. The third side close to the, I don't want to use the word adjacent again, close to the angle. Alright, so we have three sides of a right angle triangle. The hypotenuse of the triangle. We have the opposite. What is the opposite? The side facing whichever angle we want to deal with. And then we have the adjacent, which is the third side, very close to the angle. Basically, we call it adjacent because it's adjacent to the angle. Alright. What angles? We're going to use certain words, certain representations, angle symbols. Alright, we are going to use this, which is called theta. We are going to use this, which is called alpha. We are going to use this, which is called beta. Just so many symbols. We could use this, which is called gamma. Alright, so all of this could be used as angle representation. So we could talk about angle alpha, angle theta, angle beta, angle gamma. This is just representation. Greek representations in mathematics. Okay, let's look at a triangle now quickly. We are going to draw a simple right-angled triangle. Alright, now we have a very simple right-angled triangle. And from our knowledge of right-angled triangles, we do know that this angle, from basic knowledge, this angle is 90 degrees. Alright, so that angle is equal to 90 degrees. Now let's label. We are going to start by writing labels on this triangle. And we are going to call this triangle A, B, C. So A, B, C. Remember, this is basics, so we need to get the foundation straight. Triangle A, B, and C. Let's pick angle A and just make it theta. And angle C, we can call it alpha. Since this is a right angle triangle, is it okay to start by saying theta plus alpha equals to 90 degrees? Remember that the sum of the triangles in a triangle is 90. And we already know that that is 90 degrees. So this 90 plus this and that should also give us what? That should give us 180. And if that's the case, it means alpha plus theta should therefore be equal to 90 degrees. Now that's one quick knowledge that must always be with us. Alright. If we were to consider theta, then I would be looking at B, A, C. Look at my angle there. My angle is on A, but look at the movement. It's from B to A and then to C. So the angle between BAC, I'm actually focusing on angle A, which is what? Our theta there. So that's how we read it, BAC. If I wanted alpha, if I say consider alpha, what will it be? It will be BCA. So you have B, you're going to C, and then to A. Or somebody could call it A, C, B. Still the same. You're starting from A, you go to C, and then back to B. Alright, in the same vein, BAC could also be CAB. Notice that the sign angle is in the middle. Alright, so we have all that. Okay, I made this diagram as neat as possible. So we have that. Alright, okay. I think I'll just do that afresh and write my lettering again. So we said this is angle what? Theta, A, B, C. Alright. If you go back to what we said earlier on, the longest side, let's go back quickly to where we had sides. The longest side is called the hypotenuse. Alright, so let's go back. In that case, this is my hypotenuse. Can we just use H? Now, if we consider angle theta, okay, I'm going to consider angle theta. Alright, so consider. So if you're writing your notes, consider angle theta, and that's the representation there. Look at this side BC. What's happening to side BC? If I look at that, Do you notice that this side is actually opposite that angle there? So this side will be called what? Opposite. Alright, so we can call this hypotenuse, just shorten it, opposite there. Why? It is opposite the angle I am looking at. So let's label. AC is my hypotenuse, BC is my opposite, therefore AB would be my adjacent. Alright, this is basic. Once we get that in place, then we will be fine. Let's try to consider angle alpha. And I want you to write down these labels quickly. Alright, so let's consider angle alpha. Alright, I hope we're done there, writing. Okay. I am going to consider angle alpha. Consider alpha. How are we going to write alpha? It is ACB, alright, or BCA. ACB and BCA. Alright. Which side is therefore going to be opposite? If I go back to my angle, I'm focusing on the angle alpha. Which side is opposite? That. Okay. Can we then write the labels? What is AB? AB would be opposite. Let me claim this. Alright, so if AB is opposite, remember, your AC is not changing. It is still remaining as the hypotenuse. Therefore, my BC is what? Adjacent. Alright, I hope the side labelings are now okay. I hope the side labelings are now just okay. So you must quickly know what your opposite side is, what the adjacent side is, and what the hypotenuse is. So if you are going to go through anything at all, you should go through the notes on the sides. Let's go back to that note quickly. Very important. Your hypotenuse is the longest side facing the 90-degree angle. Opposite side is the side facing the angle you're dealing with, and the adjacent side is the third side. Alright. In the remaining 10 minutes in this video, we are quickly going to discuss what we call trig ratios. Trig, trigonometry. So the short form is trig, which is going to say trig ratios. We have three basic ratios. All other ratios are derived from these three. We have sine, that's the first one. The second one, we have cosine. And the third one, we have tan. Alright. When we write them in short form in small letters. Sine, cos, and tan. Alright, so we always write them in small letters. So those are the short forms. We are going to define all these ratios just now. Please note, a trig ratio is a numerical value. And not an angle. A trig ratio is a numerical value and not an angle. So all of these are numerical values. However, we will therefore be looking at sine of an angle, cos of an angle, tan of an angle. So we could be looking at what you know as, remember we said small letters, we could be looking at sine alpha. Sine alpha is a value. Alright? Cos alpha is also another value. But these are angles. We would get to see that in just a minute. How then do we define our trig ratios? What is the definition of our trig ratios? Alright, sine is defined as opposite over, you remember we've done the sides. Sine is defined as the ratio of the opposites. Sine is defined as the ratio of the opposite side. To the hypotenuse. I'm going to give you a short form of how to remember. Cos is adjacent over hypotenuse. So cos is the ratio of the adjacent side to the hypotenuse. That is cos, adjacent to the hypotenuse. And tan is opposite over adjacent. So it is the ratio of opposite to the adjacent. Tan. I hope you are taking down your notes. Alright, let's look at the 3 again. Alright, so we have sine opposite over adjacent. Sine opposite over hypotenuse, sorry. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. I want us to see something very interesting now quickly. I'm just going to write the 3 here. Sine opposite over hypotenuse. Cos, now small letters again. Adjacent over hypotenuse. Let's make that a capital A there. And tan and we normally use this representation. So ka toa. What does SOHCAHTOA mean? Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. So we have SOHCAHTOA. So this is all you need to remember. That's the trig language, SOHCAHTOA. The trig language, SOHCAHTOA. Alright, SOHCAHTOA. Let's play around with something very lovely. What do you think will happen if I were to say sine divided by cos? Just a quick trig ratio that we want to see. Sine divided by cos. What is sine? Opposite over hypotenuse divided by adjacent over hypotenuse. And I'm sure mathematically we know what to do with the division sign. what do we do? So this is sine over cos. We're dividing there. Opposite over hypotenuse. What happens here? Times hypotenuse over what? Adjacent. Do you notice this can then divide that? What do I have left? I actually have opposite over what? Remember, this is still sine over cos. Opposite over adjacent. It looks as if we've seen that somewhere. Where? Tan. Alright. So, which means that tan is actually equal to sine over cos of the angle. Alright. So tan is equal to sine over cos. We are going to introduce the angles in a minute. So sine over cos is equal to tan. Let's put this quickly in practice. Let's put this in practice as we finished our introductory video. Alright, let's have a triangle. Let's have a triangle there. And we have our angle as alpha. A, B, and C. Alright, what are we going to have? Let's label the side opposite the angle. So this side is known as my opposite. The side facing the angle 90, hypotenuse. And the third side is the adjacent. So if I were to write sine, remember, let's first write so, ka, toa. Just to remind ourselves. What is sine alpha? Opposite over hypotenuse. What's my opposite? BC over AC. What is cos alpha? Cos is what? Adjacent over hypotenuse. Where is my adjacent? AB. Do you see it's good to label? Over AC. What is tan alpha? Opposite over adjacent. Tan. Opposite. What's my opposite? BC over. What's the adjacent? AB. That's how we deal with it. And if we want to go through what we did earlier on, what is sine alpha over cos alpha? We have BC divided by AC. Alright? BC over AC. Now what is that divided by what? AB over what? AC. What are we going to have? BC over AC times AC over AB. Do you notice that divide? What do we have? BC over what? AB. BC over AB. Is that fine? Again, what do we see? Tan is equal to sine. So sine alpha over cos alpha is equal to tan alpha. Alright, I hope that makes sense. As I run this video over the next few seconds, please note, never ever do this. That is very wrong. That is completely wrong. Do not divide this. These are angles. We don't divide. So, if I were to say sine 25 over cos 25, please do not do this. This is wrong. Alright? Because this, remember, is a value as a whole. You're not saying sine times 25. No. Alright? It is not sine. There's nothing like this in math. This is completely wrong. It is the sine of the angle, sine 25. Alright, so please, we would see more numerical values as we go on. In the next video, we will deal with numbers, and then we will deal with our special angles. This is just the introduction. Alright, it's an introduction to trigonometry. I hope the introduction makes sense. Please write your notes and go through the video again. Catch you in video number 2. Ciao.